Hi, welcome to today's lesson on slope-intercept form of a linear equation. This is by far the most important form of a line, so we're actually going to spend 2 days on 2 lessons. So this is going to be part 1 of slope-intercept form of a linear equation. There are a few forms, and we're going to see quite a few of them. Not all of them, but we will see at least 3 before we're done with this year. But this is the most important by far. So what is the slope-intercept form of a line? So slope, it's abbreviated int, just like in football, and intercept form. And it is y equals mx plus b. Some of you may have seen this before. You might recognize parts of it. If you remember back to our lesson on what is slope, you recognize that m is the slope part of it. In fact, so that is, and that is part of why it's called slope-intercept. So there's the slope. We really need to talk about the b value. The b value is the y-intercept. I'm going to write it all the way out here. The y-intercept. Okay, we're going to talk a lot about what that means. Okay, in this lesson. The first thing I want to talk about from here. So the x and the y are your ordered pair. Those are all your points. Those are all the generated points. You give me an x, I'll give you a y. I'll know where to put this point on the graph. They are the x and the y parts of that. So that the m and the b are the slope and the intercept, specifically the y-intercept. And that's why we call this the slope-intercept form of a line. Well, let's talk about the y-intercept. We've talked about slope. We know slope is rise over run. We're going to come back to that a little bit later as well. We know that it's the change in y over the change in x. It's y2 minus y1 over x2 minus x1. We've seen a lot of descriptions of slope because slope is very important to us. Being able to look at a line and understand what the slope means and what it represents, very, very important. So let's talk about intercepts for a moment. Okay, so what is an intercept? Okay, an intercept is the point on a line that is also on the axis of which we are speaking. So if we have ourselves a little graph here, there's the x-axis, there's the y-axis, and we draw ourselves a little line. Well, let's switch over to black here. This spot right here that is on the y-axis and on the line would be the y-intercept. The spot that's right here, that's on that same line, but also on the x-axis, what do you know, would be the x-intercept. Okay, that is what it means to be an intercept. It's the spot that is on a line that is also on the axis for which we are naming the intercept. So the y-intercept is going to be here. The x-intercept is going to be somewhere here. Another aspect of the intercept is really important. When you're talking about an intercept, okay, the other coordinate, meaning the x or the y, is always, and there's very few always in math, okay, but it is always 0. So if we're talking about the y-intercept here, the x is 0 and the y is whatever the y value is. In this case, it looks like maybe it's about -2. On the x-intercept, it'd be x, and then the y value is 0, and maybe that would be a +1, I don't know. Okay, but that is what makes an intercept an intercept. The other value is always 0, and it is on the axis for which we are naming the intercept. Now, when we go back to slope-intercept form, okay, so I'm going to take a second, let you take a quick glance at this. All right, if we go back to our slope-intercept form, the b value is the it's called the slope-intercept form. It is the y-intercept because it's suggesting that if we were to take the slope, I don't even need to know the slope. It doesn't matter. But if I put in 0 for x, because the y-intercept is always going to have x being 0, m times 0, anything times 0 is always 0. 0 plus b is going to be b. This is the y-intercept. So when we're looking at this form, this is my slope, and this is always going to be my y-intercept. Okay? There's going to come times when you want to look for the x-intercepts, when you start solving things that aren't lines. But for linear equations, we really want to find the y-intercept. And we're going to use that to do graphs, especially very quick graphs. I may have said this before when we talked about slope. Once we understand how to read this form, we're going to be able to graph this form in like 10 seconds, maybe 15 seconds, not minutes, it'll take me longer to draw the graph than it will actually take me to actually graph it. Okay? So, B is our y-intercept, M is our slope when talking about slope-intercept form of a line. Y equals mx plus b. All right. Now, how do we use this? Let's do one where we find both intercepts. Okay, we talked about the y-intercept is going to be the most important, but let's talk about how the x-intercept plays into this as well. So we have an equation. It's not in slope-intercept form, so I don't know what the y-intercept is. I don't even know what the x-intercept is. I just have an equation here. This is actually written in something called standard form, which we're going to talk about in about 3-4 weeks. But let's find the intercepts. So we're going to, and they may ask you to do this. They'll just say find the intercepts. And what they're saying is find the point where, if I were to draw this graph, that where the point would be on this line, and on the x-axis, that'd be the x-intercept, and on the y-axis, that would be the y-intercept. Now, how do we do that? Well, if you remember back just a second ago, I said the other value is always 0. So if I want to find the x-intercept, I replace the y value with 0. Well, 3 times 0 is simply 0. So 2x equaling 6, I'm going to divide by 2, and x equals 3. What does that mean? That means 3, 0, because the y was 0, the x is 3, there is the x-intercept. Now I want to find the y-intercept. I'm going to do the exact same thing, except this time I'm going to replace the x value. So 2 times 0 minus 3y equals 6. 2 times 0 is 0, minus 3y is negative 3y, which I will then divide by negative 3, and y will be negative 2. Well, again, so my x was 0, because it always is, and my y is negative 2, and that's my y-intercept. So I can find the intercepts by replacing the other value with 0. So if you say, hey, I want the x-intercept, great, I'll just put a 0 in where the y is, and I'll figure out the x-intercept. If you say I want the y-intercept, I'll do the same thing, but I'll replace the x this time. Now I'm going to keep those two intercepts. I'm going to erase all the work here, because what do I do with those? Well, that means I can graph this super quick now. If those are my two intercepts, I can plot them. 3, 0, I got 3, that's why it's the x-intercept, see it's on the x-axis. Then I go to 0, negative 2, right? The y-intercept's right here on the y-axis. And now I try to connect the dots, not perfect, but that's what the line would look like if I were to graph it. If I were to go back to what we did before, make a table, put in some values for x to b, generate some values for y, these are what are the points that I would get, or at least these are 2 of the points, right? If I were to take the time to rewrite this equation in slope-intercept form. So let me go back and throw that equation back up there, because maybe that's an idea. Because now we know what it looks like. We know exactly what it looks like. Okay? It's going through these 2 points. It's got a positive slope, which isn't obvious. You know, you see a minus sign, you wouldn't think maybe it's got a positive slope, but it does. We'll see why it does in a moment. And it hits the y-axis at -2. Now, remember that. It hits the y-axis at -2. So now what I'm going to do is I'm going to take this equation and I'm going to rewrite it into slope-intercept form. Sometimes you've heard me say what I'm going to do is I'm going to solve the equation for y in terms of x. Remember, like my weight in terms of your weight. I'm not getting rid of anything. I'm just rewriting it. I'm really just moving stuff around. I'm taking this equation and I'm going to try to turn it into that equation. Now you remember the graph, I already knew where it hits the y-axis, it's right here. And I told you it was a positive slope, so I actually have some insight as to how this is going to play out. So I'm basically trying to solve for y. I'm trying to get y by itself. So the first thing I'm going to do, and just because of how I want it to look, I'm going to subtract this 2x from both sides. That leaves me with -3y, and then here we go. I have a -2x. I want that to be right there. That's where I'm going to put it. I have a plus b. I have a +6. I'm going to put that second, because that's where I want it. This is a lot of because I want it to be there. Okay, I want this number there. I want this term there. I mean, I could have written it as 6 minus 2x, but that's not how I want it to look. That actually is not slope-intercept form. That would be something called function form. We're not going to do that. But I'm not quite there because I don't have y. I have -3y. So I'm going to be dividing everything by -3. -2 divided by -3, a negative divided by a negative is a positive. So I get 2/3 x. And a positive divided by a negative is a negative, which gets me a -2. And look at that. There's my b value. There's my y-intercept. Remember I said I was going to have a positive slope? And sure enough I do. I have a 2/3. Okay? And from that, now I can graph this very quickly. If you give me an equation in this form, I'm in a position to graph it super fast. Okay? And let's make sure we understand how to do that. So let's take a look. Now we already know what the graph looked like. We saw it, right? But now we're going to put together everything we know about slope, intercepts, slope-intercept form of a line. So I have my x and my y. Here's how we do it. Here's how we can graph this like that. First thing we do is we look at this equation. I'm going to circle it just to give myself some, really bring it out. You know what, I'm even going to rewrite it just to give myself even more space. I really want to see it. Okay, what do I do first? This is where the b value is so important. The b value is where you begin on the y-axis. I don't know what the b actually stood for, but I have found this is so useful to just go, you know what the b means? The b is telling us where to begin. Where to begin on the y-axis, because it is our y-intercept. It's right here at -2. I could go through the process of making a table and putting in a 0 and working it out, but I don't need to, because I understand what this form is telling me. This is the y-intercept. It is where the graph hits the y-axis. So this is my y-intercept. Well, we saw in last video, this is my slope. What is slope? Slope is rise over run. And we found the slope by counting our rise and our run. But what if we already knew the slope? How do we can use it the other direction to then find the next point, which is to say, I have a rise of 2. So I put my pen on where I begin on the y-axis, and I rise 2. 1, 2. Then I run 3. 1, 2, 3. And what is this point? It's the x-intercept. Now that's not necessarily going to be the way it works every time, but we already knew that was one of the points. I am certain I am correct because it is the x-intercept. It doesn't have to be, but the slope continues. And one thing that's really cool is if I were to make this line go a little further, if I wanted to make sure I'm right, I can do it again. Rise of 2 and a run of 3. And look what happens. I land right on the line again because that's what the slope represents. It's all the points on the line. I can do that forever. I can even go backwards. I could go down 2 and back 3. Down 2 and back 3. Okay? Because a negative divided by a negative would have been a positive. So I can do it in either direction. That's how I can use slope and the y-intercept to graph a line super fast. Okay, let me do one more example here. Okay, erase all of this. And I'm just going to make up an equation right off the top of my head. I'm going to put it in slope-intercept form. I'll make my life easy. So y equals, let's just say negative 2x plus 5. Yeah, seems reasonable. So now I have two things. I have a slope. That's negative 2. It's this number right here. Now, you saw, for slope, I always want a fraction. What if I don't have a fraction? I can make anything a fraction by putting a 1 under it. So now I have a rise and I have a run. I have my y-intercept. And sometimes they just list it as one number, 5, because anytime you say intercept, the other number is always 0. So really what I'm saying is the point 0, 5. But you know what? I don't even need that because I just know this is where I'm going to begin on y-axis at the number 5. So I'm going to draw myself a little graph. Okay, remember I said we're going to be able to graph really fast now once we have it in this format. And here we go. I begin at 5 on the y-axis. 1, 2, 3, 4, 5. I put 1 dot. I'm halfway done with my graph already because the only thing I've got left to do is put the other point on there and connect the dots. My rise is negative 2. We said this in the last video. Negative rise means we're going down 2. The run is positive 1. It's not negative 1. Don't make them both negative. The 1 is positive. So I'm going to go down 2 and I'm going to go over 1. And there's my graph. Negative slope, negative slope. Y-intercept of 5, y-intercept of 5. That's what makes this great. You can read this equation and know what the line should look like. I can walk up to the line and know what the equation should look like. Because I can look at it and see, hey, I could have found the rise and the run by counting the down and over 1. I could see where it's hitting the y-axis at the number 5. All of these things make this form so valuable to mathematicians because it's immediately evident to us what the graph should look like, or the graph means the equation. Okay, they're interchangeable. Okay. So, graphing from slope-intercept form. You begin at the b value on the y-axis, no exception. And then you use what you know about slope, rise over run, to put the next point. And you can keep going. If you wanted to put more than one point, you could keep going. It would never vary. Again, go down 2 and over 1. You can see I land right on the same graph over and over again. Once you understand that, graphing becomes super easy from this form. Okay, maybe a little trickier to go back, but not by much. Once you start to realize, hey, it hits here at 5, that's the +5. Hey, look, I could count rise is 2, that's down 2, so negative, and run of 1. I could put this into that pretty easily based on my information. All right, this is the first part. We will see a second video on how to find slope with 2 points, how to come up with the graph, and a few other things, tying all the loose ends about slope-intercept form together. And it's not the last time we're going to see it, because we're going to be using it a lot when we get into solving systems. We're going to use it again when we see the other forms of linear equations, including point slope and slope-intercept and standard form. So we're going to use it again for all those forms. Okay, so this is a very important form. We really want to understand it. So one more time, y equals mx plus b. Oh, and I'm going to say it one time. So b is where we begin on y-axis, and m is how we move, the rise over run. Okay, I hope that makes graphing so much easier for you, and I'll see you in class.